Hello, welcome all. Today is the ninth session. So we will discuss mostly about the week 8 problems today. So yeah, that is a because so it has been informed that many of you are facing problems regarding this numerical thing. So solutions are already provided to you, but yeah, we'll discuss about those things in detail. Uh, 3 more weeks are there to go. So we hope we'll practice some additional questions from the previous parts also as well, because not much are left in the course. So in terms of the numerical portions. Okay, so maybe in the next part also, in the next assignment 9 also, there is some things, and then we are okay. I mean, we are done with almost done with the numerical portion. So you have to practice well. So in the next, so today we work on for the week 8 only. So next week we'll finish it off with week 9, and then we will start practicing for few more about in the from the previous week's chapters. Okay, so that will help you all, I guess. Okay, so one more thing. Yeah, thanks. So okay, so I can start actually. People are joining. So before, okay, let me share my screen. Okay. Okay, so one thing to mention that there was a confusion regarding what will be the question pattern in the main exam. So that as the course instructor informed that the question pattern will be the exam will be auto-evaluated without any human intervention. The pattern will be similar to what they encountered in the weekly assignments. Most will be objective type questions and some will be numerical. So as you have seen in throughout the assignment questions, so you can understand that you have to be precise on answering questions, because I mean, for the especially for the numericals, so there will be, I mean, since this is not it's an auto-evaluated thing, so you have to be careful about what exactly they are asking. You have to be very much precise on that, so that you be careful on things. Because I mean, after the examination, nothing. I mean, I don't think it will be considered anymore. Like for the assignments, it is okay, but after examination, I'm not sure what will be the case. So you try to be cope up with all the things and patterns that have been asked throughout the assignment. So you be very much accustomed with that and practice well, so that you can do well in the exam. Okay, so with that note we can start today. So we'll initially talk about little bit about the theory part also. So and then we'll solve the questions. Okay, so I think that is okay for you. So yeah, so basically that this chapter was about the testing of hypothesis. So you all know. So hypothesis, I mean, you know that what is hypothesis and all that you have read in the earlier chapters. So and then there are several types of tests through which we can, the test or the viability of the hypothesis can be tested. So among them, mostly, two of the names have been taught in the course. That is the J test and the chi-square test, right? So we will go one by one. Okay. So first, I will just go through the slides, because I guess this will be important also to know the background a little bit. Otherwise, it will be difficult. Only, I mean, you can do solve the problems with the once you know the formulas, but still it will be better to know little bit about the what is the background of these things. Because sometimes what happens, like questions not related to, not exactly numerical, but I mean a one liner questions that might come, so that you have to see. So that's why, like, you have already taught in the class, but still, this has been instructed also to because to help you out in these things. Okay, so yeah, let's start first. Then so, hypothesis testing is a technique for interpreting and drawing inferences about a population based on sample data. It aids in determining which sample data base support mutually exclusive population claims. Okay. Now there are two hypothesis testing things are there that you know that I mean two through which we can test, that is this null hypothesis and alternative hypothesis. We have already read about that. So null hypothesis is what the it is the assumption that the event will not occur. Like we can say that up to a certain level, if this happens, then this will be the hypothesis accepted, or up to a certain confidence level, and beyond that, this will be rejected. Okay, so that is the null hypothesis. It states that the event will or the hypothesis that has been stated will not occur. A null hypothesis has no bearing on the study's outcome unless it is rejected. So H0 is the symbol of that, and alternative hypothesis is just the opposite of that. Alternative hypothesis is logical opposite of the null hypothesis. The acceptance of the alternative hypothesis follows the rejection of the null hypothesis. Basically, we are accepting the hypothesis. So that is the alternative one. So for a certain condition, right? Okay. So then, so we are directly coming to the test. That is the two tests we will read. That is the Z test and the chi-square test. The first one is the Z test, right? So what is Z test? A Z test is a statistical test used to determine whether two population means are different when the variance are known and the sample size is large. So now it is important to note that sample size is an important factor here, right? Sample size, because for the because if you read the central limit theorem, so sample size should be at least 25. I mean, if it is less than that, then everything changes. So if it is greater than 25, so then this comes under a normal distribution section and is accepted. Okay. So the test statistic is assumed to have a normal distribution, and a nuisance parameter such as standard deviation should be known for the accurate Z test. Okay. Now, a few points about that. Z test is a statistical test to determine whether two population means are different. That we have read. Now, there's a hypothesis test with Z test follow the normal distribution. This is also said. Now, third one is we have to determine the Z score or the Z value from a given formula or already derived formula. It is also closely related to t-test, but t-tests are best performed when the experiment has a small sample size. That's what we are saying, that when the sample size is smaller, when it doesn't come under central limit theorem, so then it will perform the t-test, right? So we'll not talk about t-test here. Z-test assume that the standard deviation is known, while t-test assume it is unknown. So we can derive the these things from the t-test, right? So we will not go in detail about that. Now, this is also said that the sample size should be greater than 25. Okay, it is in some cases you may read that it should be greater than 30, but here as informed here, so convention wise now it is accepted that it should be greater than 25, not greater than 30. You might confuse, but when you are calculating the things, you don't get confused about this, because you have to consider once it is greater than 25, then it is a normal distribution, right? In some standard textbooks, it is reported that it should be greater than 30. So don't be confused. What is taught in the class? I mean, you just go with that convention. Okay.
Yes, some textbook and some theories it is
Yeah, yeah,
mentioned 30, above 30.
yeah. About 30. So, but I mean, yeah, I mean, but that's what I'm saying. So you just go to the convention that has been taught here. So that will be easier for you to solve the problems, right? So yeah, I mean 20 is greater than 25 is also accepted in few books if you closely look. So this is the case also there. Now, so then the next point is while conducting Z test, the null and alternative hypothesis. should be you have to check, and alpha and z score should be stated, or you have to evaluate from there. Now the test statistic should be calculated. That is the value basically from a table. Then you can clearly confirm what is the case, and so that is the thing. Uh, I mean, these are the main points of these things. Now, when to yeah, you can see here I've made a mistake. I've copied from somewhere, so it should be 25. It's not 30. It's okay. Not a big issue, but you be careful since this is the thing that has been informed here. Okay. Um, Now, so this part is important. So when we perform a statistics test, we are trying to judge the validity of the null hypothesis. We are doing so with an incomplete view of the population. Our sample is our window into the population. The larger the sample size, the bigger our window. However, without a full view of the population, there is always a chance that that our sample will lead us to the wrong conclusion. So, if let's say if you take a very smaller sample size, then the problem will be that the actual value that should come, I mean, and the value you obtain, that will differ very much. So I mean, testing wise it will differ very much, and then there might be a chances of being the hypothesis false or rejected to up to a certain confidence level. Okay, so that is the case. Now so now basically we can come to the, so these are the some of the things that you should remember while doing problems related to this. Now, so what I understand, it checks basically if the means of the two different populations are different or not, provided the data follows a normal distribution. So check boxes are that the distribution should be normal. It means the sample size should be greater than 25, and from there we can understand whether the mean value that is coming from different populations are same or not. For this purpose, the null hypothesis and the alternative hypothesis must be set up, right? Now, to calculate the Z value, we have to we can apply the formula that we know already, that is z equals to x bar minus mu upon sigma by under root n, right? So this is the standard error, you know, but this, for calculating this we will come to a new formula. So so what is x bar? X bar is the sample mean, mu is the population mean, and sigma is the population standard error, right? Okay. So, uh, okay, I'll come to the formula. So before that, how many types of tests are there, or how many types of Z tests are there? So you can see there are three major tests, like left tail test, right tail test, and two tail test. Okay. You don't have to worry much about the problem that will be discussed here, but I mean just to know only. So you can see that this depends upon the which side of the of this curve you are taking, basically the left side, right side, or the both side if you are considering, right? So, and how can you reject the null hypothesis? So for the left tail test, basically, say H0 is mu is equals to mu zero, right? And for alternate hypothesis, this mu should be less than mu zero. So we can see from here. So this is the critical value that is getting from here, and it should be or equal to that value. And for the alternative, it can be greater than this one. So decision criteria, if Z test or the Z statistic that or the Z value that you obtain from the formula is less than the Z critical value, then we can reject the null hypothesis, right? So if it goes beyond this region, or rather this line, so or this area, then this should be rejected. So similar for the right tail test. So if it goes greater than this value, so it will be rejected. And yeah, and for the total test you can understand. So it's for the both side. So these are the different types of Z test. Okay.
For right,
Now,
it has
yeah,
to be rejected, or
yeah. So sorry, right? What did you say?
for the right tail
Yeah, for the
test,
right case, if z,
approximately.
yeah, for the right case, if the z value that is coming is greater than this critical value, then it will be rejected. In this case, if it is less than this one, I mean the if you go, so if you consider this as an axis, so if it is x-axis and there is a minus value and the plus value, so if you go beyond the critical value at this side for the left tail, that will be rejected. So let's. So if this is less than the critical value, and for this side, if this is greater than this critical value, okay. So it means that if you consider this is the bar, if you go at this side, so this will be rejected. So if you consider this one, if you go this side, this will be rejected. So this means this is a lesser value since in the negative side this is going, and this is a positive value since this is going to the positive side, right? So that's why I mean that's how it will be considered. Okay. Okay. So yeah, and for the two tail test, you can understand. So this is just to know. Now, what will be the case for the two sample test? So this was we are discussing for one sample case. Now we're coming to the two sample case. So for the two sample case, what will be the formula? So formula will be pretty simple as that. A two sample Z test is used to check if there is a difference between the. I'm sorry. Did someone say anything? So the z test, so the formula is coming out to be x1 bar minus x2 bar minus of mu1 minus mu2 upon by under root of this value. So this is the standard error. So that is calculated for a given set of different set of values, right? So if you clearly come to the formula, the z value is x e bar minus x e bar. So that is the mean of these two sections by standard error, estimated standard error, right? So estimated standard error, how to calculate that? So estimated standard error is basically the standard error of, let's say, x square by x or n of x, that is the number, plus standard error square of y by number of y, and square root of that. So with this value we can, with this formula we can calculate the z value of a given data set, right? So and from there we can correlate to the z table, and then we can comment on up to how what confidence level we can go for what, right? Okay. So now, if we look at the problem one of assignment 8, so this is very simple and straightforward problem. It is given that if you, in a hypothesis testing experiment, this is the problem that they are giving. You have collected data from two populations. You may think of anything from your discipline representing the populations, whatever stream you are from. We have obtained the sample mean and standard deviations. Okay, so this is the population 1 and 2, and for 1 the number of sample size is 52, and for 2 it is 47. So both are greater than 25, so there's no problem in that. Now the mean values are also given, this and this, and the standard deviations are also given, right? So now you have to calculate Now you can calculate. They've asked for if the hypothesis can be stated as A0 equals to, that is the null hypothesis, mu A equals to mu B, and alternative hypothesis, that is mu A greater than mu B. Obtain the test statistics up to 3 decimal, means the Z value, and check if they are enough ground for rejecting the null hypothesis. So if nothing is, so this is the, I mean, this is the overall thing. So they have divided the question. Now you have to obtain the Z value and the null hypothesis with a 95% confidence level, right? So that you have to you should know. So to solve the problem, what you have to do, since the number of sample size in each category is greater than 25, we should apply the Z test. Okay, that is first checkbox that is done. Then we have to calculate the estimated error. So error, for the error calculation, we have given the formula, and the formula is this one, right? This is the standard, is the formula for estimated standard error, standard deviation square upon number of, I mean, and the summation of both of the data set and square root of that. Right? So here both the data sets are given. And so this was the standard deviation value for x, and sorry, a and b is here. So this and this, if you look, and the data size is 52 and 47. So under root 5.65 square by 52 plus of 4.95 square by 47, and summation of that and root square root of that, right? So it is, the value is coming out to be 1.065. So this is critical, right? Now this,
I'm getting
so
Okay.
1.6.
yeah,
Excuse me. Yeah,
yes.
that's why in last lecture I had discussed regarding to this topic. I written cannot. That time there was confusion. I mean, not with you, but another he was there. So we all are confused that we should reject or we should not reject. In yes, we can reject. Can be rejected with 95% confidence. Answer is, but I had mentioned cannot, so it was right in assessment.
uh, yeah, you so okay, let me check what is the question. You can or cannot.
Yes,
So you have answered cannot, and that was
yes,
correct, that is given.
correct. Yes,
So, and here it is saying the null hypothesis can be rejected. So, yeah, so it means there's a conflict, right?
yeah.
So, what is the answer given there? I need to check actually. Uh, what was the answer given in the respective section? Let me check.
Given, yes,
Actually, it is.
Actually can reject.
Yeah, it should be can reject because the at least the value is
Z
showing
value
there.
is 2.065.
Yeah, yeah. So that's what I'm saying. So since the value is given like that, it should be. But her confusion is that she mentioned cannot, and still. So yeah, the answer is can, right? So that is given. I don't know. If you have gotten marks, that is okay. But I mean, the answer is simple.
okay.
If we look at the solution, so it will
That means
be,
the value should be greater than 1.96, so we can just
you can
we can
reject it.
accept. Otherwise, we cannot.
Yeah, for the 95% confidence level. If it would have been asked for 99%, then this value would have you had could be greater, right?
Okay,
So for the 99 and 95, you know the value, right? What should be the value? So
okay,
since this is for 95, this value is 1.96, and from that's why you can reject for this case. Clear?
okay, sir.
Yeah. So yeah, so this is a confusion then. So since the z value is coming out to be greater than 1.96, the null hypothesis can be rejected with a 95% confidence level, right? So this you just remember, it might be, I mean, these values will be changed only. I mean, questions will not come very critical or something like that. Similar kind of questions will be asked in the exam as well. You have to just remember all these things and the values and formulas, right? Now, so that's why a problem we can do right now, a similar kind of problem. Only the values are changed. So this is from the okay. Let me. Oh, oh, sorry. So no, for not for this case. So for this case, actually the problem was almost similar in the previous year. So now we can move on to the problem two. So that previous year question we can try to solve it here. Okay, so I think this is okay. This problem is okay for all. Now we can go to the next problem. So the next problem was a drug is proposed to lower total cholesterol. A randomized controlled trial is designed to evaluate the efficacy of the medication in lowering cholesterol. A total of 52 participants are enrolled in the trial and are randomly assigned to receive either the new drug or a placebo. The participants do not know which treatment they are assigned. Each participant is asked to take the assigned treatment first. At the end of 6 weeks, each patient's total cholesterol level is measured and the sample statistics are given. Right. Now you can see, so sample size is given, mean values are given. So sample size for two sets is 32 and 28. So you can understand both are greater than 28. There is a normal distribution. Mean values are given and standard deviations are given as well. So is there statistical evidence of a reduction in mean total cholesterol in patients taking the new drug for 6 weeks as compared to participants taking a placebo? Obtain the test statistics up to 3 decimal places. So this is a similar problem, right? So if you go to the solutions, you can see. So first is the null hypothesis. Mu we have to consider that mu control equals to mu experiment, and alternative is control greater than experiment, right? This is the standard format. Now we have to evaluate the standard error. So these values are given. 28.2 square by 28. Since this value is yeah, so this is 28.28, and here it is 29.9 square upon 32. This value is coming out to be 7.506. So the test statistics is how much is coming, 1.172, right? Since the z value is less than 1.96, the null hypothesis cannot be rejected with a 95% confidence. Okay, so the earlier one was greater than 1.96, and this is less than. So this cannot be rejected, and the earlier one was rejected. So I mean, this is just the, you can see the values are just the opposite, but the fates are, that's why the fates are changing, right? So you can now try to solve a problem. So I hope these problems are okay, right?
Yes, sir.
Yeah, okay.
Yes, sir.
Yeah, yeah. So now you can go to a problem. Just the values are changed. So this is a previous year problem. So you just try to solve it. Same, I mean, the writing of it is same. Only the table values are changed. So this will be the case also in the exam. So you just try
So
to solve
this
it now.
is 25%, 25 number of samples. So Z statistics material, no?
So that I mean, so what is it? It is at least 25, okay, or greater than 25. So for 25, it you should consider to be greater, right? I mean,
Okay,
you
greater
should
than equals to we can
yeah,
consider.
greater than equals to, yes.
Yeah.
So
Okay.
that's why it will be Z test. No problem with that. So you can take some time and try to solve it.
And their standard error is 8.168.
Yeah, I just I mean let others do. So I'll take the answers. Just wait for some few minutes more.
So null hypothesis is accepted
Okay. Okay. So
as a value of
yeah,
z
yeah, value.
calculate values
Yeah,
less
value. You
than.
can just hold on for now. Let others finish. I mean, give some time to
Okay,
others.
sir.
We'll take the answers.
Okay, sir.
Yeah. Yeah. Okay, I think now it's enough time you've gotten. So, yeah, I mean, let us solve the answers, right? So, yeah, I've not solved it because I wanted to do it here. So, we can just tab and right. So let me copy the values there. How to do that? Maybe. Okay, okay. I will remember the values. So for the sample one, the
You
values at
will
27. Yeah,
will tell
yeah.
you will tell you you go to the other slide.
Okay, okay, yeah. So that is better. So now first thing is we have to calculate the ESE, right? ESE, right?
Yes,
Uh,
error. Yeah, standard error.
Standard error, right? So I mean, how to calculate that? Now tell me.
Uh,
So
Standard
it will be
deviation square under root of standard
uh,
deviation square
under root of
divided by
standard.
number
So first is the
of
summation of the
summation.
so. Hmm. So what is the values? You just tell me. Go on.
28.7 square divided by 25.
Sorry.
plus 30.3
Yeah,
square divided by 27.
28.7
Square
square by
divided by 25.
divided by 25.
20.
Okay,
Yeah. Plus
plus yeah,
30.3 square.
plus 40.3 square.
30.3 square.
30,
Okay,
30.
yeah, 30, okay, 30,
30.3 square
30.3 square by
divided by 27.
27.
27. Yeah, so how much is the value coming? It is
Under
coming
root
out to
of
be
32.94 plus 34.002. It's around
Yeah.
8, 8.1888.
811.
so the square will be right. So I can let me
Square
Yeah.
root, yes,
let me do
32.94,
square root of this and the value is 32 point.
94.
No, 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 no,
Und,
no.
under root,
No,
no,
it
first
is
of all,
coming out to be
it's under
Sir,
root
sir, it is
823.69.
8.18.
yeah,
8,
it is
8.18.
8.18. Correct, correct. This is 8.18. Sorry.
8.18, yes.
Yeah,
Yeah, 8.18.
8.18. So now we have
1.
to evaluate the Z value, right? So we have gotten
Z.
this one. So Z
20,
value will be
uh,
Z value will be the difference between two. So
8.85.
so
Bar x, xn minus bar
yeah, yeah.
xn.
So tell me the values.
Yeah. So xn, that is the new drug, is 195.9 minus
195.
My
195.
point
point
285
9,
is
Okay, okay, okay,
199
195.9
okay. I missed it. Yeah.
minus
195
195.9 minus
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 227.4
227.
0.4.
227.
Yes,
227. Yeah.
227.4. So
point
we'll
4.
take the mod value, right? We'll take the
Yeah,
mod
yeah.
value and by divided by 8.18, right?
Yes.
8.18. So it
Yeah, so
comes
how much is the
around
value?
3.84,
3.85, right?
3.85.
Yeah, yes,
3.85.
3.85.
correct.
Yes,
So
3.85.
now so what will be the case?
So
Should
this
we
is
accept or
having reject, reject.
so this is greater than 1.95.
Greater than
So
1.95.
for okay, now you understood, right?
95%
So this will be rejected since this value is greater than for a 95% confidence level.
confidence. Yeah.
Yeah. Now, if it is asked for 99% confidence level, what will be the case? What is the value? Do you remember that?
Sorry,
2.58.
Yeah,
2.58.
2.58. So,
99% you said, no?
yeah. So in that case also it is rejected, right?
Rejected, yes.
2.58. This is important to remember. And do anyone remember for what is the value for 90%?
It is 1.68 something.
Around
1.65.
1.68. Yes.
0.64.
65.
1.65.
64.
1.65.
64.
Yeah, yeah.
Yeah.
Yeah, 6465. I think
Yeah.
65. Okay. So yeah, these three values are important. So 1.65, 2.58, and 1.96. Right. So these three values you remember. So this will not be provided to you. You have to remember just these things, right? So okay. So now this problem is done. And so
Hmm.
for this Z days, these kind of problems will come only. This is very straightforward. Standard sample sets will be given. You must understand that since our data set will be given, that is only greater than 25. 5, right? Otherwise you have to take a call because that will not be accepted. So this is the case for z test. Now we will come to chi-square test. So what is chi-square test? So the chi-square test is a statistical procedure for determining the difference between observed and the expected value. Uh, anyone is unmuted, please mute. Okay, so the chi-square value is the difference between the expected and the observed data. The test can be also be used to determine whether it correlates the categorical variables in our data sets, and it helps to find out whether a difference between two categorical variables is due to the chance or a relationship between them. So basically, they what they want to mean is that if once you are getting this value, so that is coming by chance, that is not exactly the not a random data that you are getting. Rather, this is actually corroborated or related to your data points that is you are getting. So that is to justify or test that we use the chi-test. And simple formula is that the chi-square is difference between the observed value, uh, difference between this observed value minus the expected value, square of that divided by the expected value. Simple as that. So for that, you need to know the degree of freedom also. So I'll come one by one. So what is degree of freedom? So degree of freedom in a statistical calculation represents the number of variables that can vary in a calculation. Number of variables. Variable means the values that can be changed for a data points, or for a sample set. So the degree of freedom can be calculated to ensure that the chi-square tests are statistically valid. These tests are frequently used to compare observed data with data that would be expected to be obtained if a particular hypothesis were true. Okay. Now here also we'll put the null and alternate hypothesis. Now when to use the chi-square test? A chi-square test is used to determine or examine whether the observed results are in order with the expected values. Now when the data to be analyzed in form of from a random sample, and when the variable is the question in the question is a categorical variable, the chi-square provides the most appropriate test. As what I was saying, for a random sample, from a random sample you are taking a value, and whether that value is exactly matching or correlating with your total data sets. So for that we use this chi-square test. I mean, for this kind of experiments, or this kind of knowing whether for a particular data is correct or not, we
So
use it.
so you mean to so this means that we are comparing the observed value versus like the entire population, right? Like
Yeah, kind
that
of
is,
like that.
yeah.
Yes,
So
yes,
it
true.
should represent the population, the sample what we are withdrawing. So random
No,
sample. Yeah.
yeah, it was for a random sample. Yes, you are correct.
Yeah.
So it is mostly it's commonly used for analyzing this kind of data. So this type of data is helpful for researchers who are studying survey responses. So these are okay. I mean, this is not very related. Just randomly copied. So now the thing is that what kind of carbs or can be there or can come there to understand these things. So k value is the, or the chi value, that is that comes after calculating these things. And for different k values, different probability distribution comes, right? So if you see different patterns are there actually. So once the k value, that is k value is between 1 and 2, and the chi-square distribution curve is shaped like a backward j. You can see this is a backward j, right? And the high chance that the chi-square becomes close to 0. Okay. Now, once the values are greater than 2, this shape starts changing. Basically, this is not from this directly, not goes to this, but after this like becomes this. this with increasing the k value this, and then it finally becomes this, right? So when k is greater than 2, the shape of the distribution curves looks like a harm that and has a low probability that chi-square is very near to 0 or very far from 0. It will be in between. The distribution occurs much longer on the right hand side and shorter on the left hand side. The probable values of chi-square is chi-square minus 2. Okay, so we'll come how to calculate. So a chi-square test will give us a p-value. Another thing is that p-value is calculated from here, and this p-value will tell us whether our test is significant or not. From the again from
P-value, exactly what is the meaning of p-value?
p is the probability value. P is the
Probability
probability.
value, right?
Yeah, p
Okay.
is the probability. Okay, and
So basically, the significance what we see, that is the probability on that significance.
yeah, correct. So here, if you look at, so this is the probability value. The y-axis, if you go, so these are the probability values, right? So this you can get from this once you apply the formulas and all. Now, okay. So now here also you have to perform this null and alternate hypothesis that I have said. And another important thing is that you have to calculate the degree of freedom calculation. So in elementary statistics, we usually get questions along the degree of freedom and the alpha level. So alpha level is okay. I mean, the alpha is the for this confidence level that you know already. Now this degree of freedom you have to calculate for calculating this chi-square test. Okay, and how to calculate this degree of freedom? So degree of freedom is basically this value r minus 1 minus into c minus 1. This r, what is r and c? R is the number of row and c is the number of column for a given data sets, where r is the number of rows and c is the number of columns. If the observed chi-square test statistics is greater than the critical value that is given, the null hypothesis can be rejected. You can understand, right? So these are the few things that you have to.
There one question I have.
Yeah.
Sir, here the formula of degree of freedom, this formula is for only probability calculation. Means when there is a significance of probability.
Mhm. So P is P. No, I mean this P value signifies the probability, right?
Okay, now a degree of freedom calculation, that is r
Uh-huh.
minus 1 into c minus 1.
Uh-huh.
This formula is for only when we'll go for the p value determination. That time we will take it as a degree of freedom. This
Yes,
formula
when
particularly.
when we will go for this chi-square value determination, basically, then the
Everywhere we will put this formula
sorry,
for
yeah,
everywhere,
uh,
but
not
somewhere it is
everywhere. So
n minus 1 plus m minus 1. No, some formula is there also.
I mean, this is basically same thing. So I mean, in whatever format you write, so for a given data set, the row and the column you have to calculate, you have to consider. From there, you can calculate easily. So I mean, it doesn't matter. I mean, how you represent the thing. So it is simple as that. You just remember what is the row. And just calculate what is the row, total number
Okay,
of row and the total number of column. So you will understand. I mean, now. So once you see the problem, so
okay,
these are okay, right? So this was a problem for problem number 3. So it's a pretty large problem. So one thing you must remember that for this you also need the support of this chi-square table. So I hope that will be provided while the exam. Now, if you look at the problem, what is given? So, suppose the scientists have hypothesized that a substance V decreases the possibility of infection by COVID-19 virus. That is, it acts as a vaccine. You want to test in two separate laboratories if it is really effective. You gather a number of people, a proper sample of all ages and sex. You apply V on the 20 people in a lab A and 200 people in lab B, and a placebo on 200 people. So you can understand. So total 3. So after a year, you take a survey and find that out of the people who got V in lab A, 40 got sick of COVID-19. Out of those, got V in lab B got 36, got 6, and who got placebo 50 got 6 sick. Okay, so using chi-square test with a significance level of 10%, what conclusion can you reach regarding the efficacy of the vaccine? Okay, the answer should be given as that is a chi-square value intended to reject the null hypothesis with a round up to 3 decimal. Okay. Now, let's see the solution. So, we have to first figure out, or we have to uh, make a table out of the given data point that is given there. Okay, so total number. Three things are there: lab A, lab B, and a placebo is there. So placebo is basically the mental thing. So you understand, you know that. So there is no vaccine was actually given. So, but they are, I mean, it's kind of like thing like that. So, but they have been told that they have been given the vaccine. So kind of like that. It's just dummy of that, not the exact actual vaccine. Okay. So that is actually a control. So now, this is for the placebo. This is for the experiment A, lab A and lab B. So for the placebo, total number was 200, got sick 50, and not got sick, so 150. For lab B, got sick 80 and not sick 180, so total was 220. And in lab B, total got sick 36 and not sick, so 164, total was 200. So total sample size is 640, and here the total seek is 136. So if you look at here, these are the values given. So now,
Excuse me, sir.
yeah,
Actually, I just want to know that you had mentioned expected. So how we can bifurcate this expected value? Seek and not seek.
yeah, that's why I'm coming. So so this so what up to what chi-square level this is given. So sorry, I'm not, so what significance level, 10 square significance level is given, right? So now,
So that goes to 0.01%.
yeah, that goes to 0.01%. And the value that is expected value that is given, let me check what is this expected value. uh,
Yes, so the expected
The
value is need to
question
calculate
of
it.
so,
control group,
sorry,
The expected value we need to
25%
calculate.
from the control group,
from the control
50
group
got C.
Sir, here the total, how did 640 comes like 200 when you're going to add this three,
It should
it
be
will
Yeah,
six
yeah,
hundred twenty.
620.
some problems are there. I agree. So this was the solution given. I just copied from there. So yeah, so some problem is there actually. So it should be 620, not
20.
640.
yes, sir. Similarly, one
Yeah,
Um,
carry on.
in place of 136, it should be 126.
Sorry, I didn't understand. So
So, in place of 136 also, it would be 126 when we're
in
going to
place of
add
uh, 136, it should be yeah. So it
126
226.
yeah, yeah, 50, 40, and uh, 50, 40,
40
and
and
36, right?
36.
It should be
Yes.
120. Correct. It will be 120.
Similarly, not six case also, sir. The total is coming out to be 494.
Yes. I think in every case they have
Yeah.
added 10 more. In every case they have added 10 more. So that is a problem. Okay, this I will mention that is not a problem.
Can you can you tell that how
Yeah,
did you
yeah.
arrive at this expected values?
yeah, that is more important to know
Yeah,
because
expected. I am now. I am also confused. So that it is mentioned that the expected probability of getting sick is 50 out of 200, that is 25. So 25,
25%.
yeah, 25%. So I mean, let me see. So is it
The
mentioned?
sir, the formula which I know for calculating the expected value is which is equal to the expected value, which is equal to the multiplication of row and column which we are calculating divided by the total number n. So
Yes.
we are going to calculate in case of place bow. Then we have to
Huh.
do the calculation like 126 multiply by 1 second, sir. Then we're going to multiply 126 with 200
200.
divided
Yeah.
by 620.
620. Yeah.
Mhm.
Yes, yes, yes.
So this value is coming out to be what?
So the expected value in case of place bow, my value is coming out to be 40.64.
Okay.
I did same way in the assignment and I got the wrong answer.
Yeah, yeah, I understand.
Same here. Same
Yeah,
here.
same way I did also. I also
Okay,
got
okay,
wrong
okay.
answer.
I mean, see, I mean, we are now sure that the values are already wrong. So, yes, that is not a problem. That I will inform. Okay. So now you just carry on with the answers
The expected value in case
expected
of
value.
the
Yeah.
place bow,
Hmm.
40.64.
So how are you calculating that? Yeah, that you
So
mentioned.
when we're going to multiply the total number of column with the total number of row,
Total number of
the
column with the total number of rows. So
number of
total number of.
row,
Uh-huh,
column is 126.
uh-huh.
Uh, Excuse me, if you are going to add total number of column, that is 126 after adding the expected value also. So how
Yeah,
we
yeah.
can, yeah, so how we can calculate if we don't know the expected value
No,
previously,
no,
then
no.
how?
No,
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 no.
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 This is
No, no, no,
This
no.
is
It
the
is
control.
adding
Adding,
the control value,
I'm
Adding
not
the
adding
control only.
experimental value.
Okay.
this is
This one,
126
this
into
one, and this one.
220
Only
divided
These
by
three.
620.
126 multiplied by
Right?
200
Two,
and
two.
divided by 620.
Yeah, correct.
One, yeah,
Correct.
yeah, correct, correct. 126 into
yes, yes.
494
22.
divided by
200.
620, right?
No,
Yes,
no,
sir.
no,
Right.
no.
Sorry.
126 into 200 divided by 620.
Expected formula, please repeat.
The formula is the
Num-
total number of sum column
yes.
multiply by the total row, total sum of the row divide by the total, the capital N.
Yeah, that is
Here
right,
it is
right. I calculate that is right. 40.64. 40.64. It's right.
40.64.
Yeah, right.
6 by 64.
Yeah, that is correct.
So for a
40.64.
Please,
lab
can you
A,
repeat that formula?
so lab A it is 126 into 220 divided by 620.
For a
Please
lab A.
repeat.
Lab
Yes,
A.
sir.
Yeah, for lab now you go on.
Yeah,
For
it
lab
is
is, sir, my value is coming out to be 44.70.
Yeah, let me calculate. So this is now the it's
126 into 220 divided by
126 into 220
220.
divided by 620 is
620.
44.70, right?
Yes,
Yes.
sir.
Yeah, correct. Now, uh, and
Lab
lab
B is
B,
126 into 200 divided by
620.
620.
so it is
40.64.
coming up to 40.64, right?
64. Yes, sir.
Yes,
Yes,
yes.
correct, correct. So now after that, what to do?
Sir, similarly, we calculate for not sick also.
Excuse me, sir. Sir, can you repeat how we have find out that expected probability?
So expected probability is total sum of
Column.
this, yeah, total sum of the uh, number into the value in that row. I mean the row value divided by the total value in this. Divided by the total value. So basically for control one, if you consider this total value is 126, so it will be 126 into 200
Total sample
total,
value.
and the
Yes, yes.
sample
Correct,
value
correct.
divided by
Correct.
Total value in
620,
this
correct?
category.
620. Yes.
Hmm. So the value is coming out to be 40.64 for lab A and control and lab B, and for lab A it is coming out to 44.70, right?
Yes.
Yes, sir.
So the this gives the expected values. So now we have to calculate the, so now the total probability will also be changed. The probability that is considered here, so that they have
It will be
136.640.
0.20.
Yeah,
0.20. Yeah. 126 divided
126.640.
by
Yeah,
620. So it will be
620, correct.
0.20.
So it is 20, 0.20, right?
Yeah, 0.20.
So 0.
Uh, Sir, while putting this lecture slide on sharing drive, so it's going to be improved, or shall I make the note? What is it?
Sorry.
I mean, while putting this all in a drive for the
Uh-huh.
reference preparation for the exam, so all this will be corrected in this slide, or shall I
Yeah,
mention
yeah,
the note
this will be
here?
corrected. It will be corrected.
Okay, sir. Thank you.
Yeah, because so I'll, and for this week specially, I'll need some time because I have to inform this to instructor. So once
Okay.
they make it correct, I will upload it. Okay.
Okay, sir. Okay.
Yeah, yeah.
Thank you.
I'll because this is a problem, because this is a
Yeah.
problem. So I'll mention it
So
there.
whatever values we have got, we can round up that values.
Uh, s- so sorry, whatever values you have got, but
We can round up those values. Like, for example, we have got 40.70
yeah, yeah, you have to
or
round. Yeah, yeah, you have to round up.
round up this.
Correct.
So we can make
Yes.
45, 41, and 41 uh, accordingly.
So now if you we know now the numbers are okay, numbers are, I mean, a bit wrong, that is given there, or calculated here rather. Uh, so now what will be the procedure? Procedure will be you have to calculate the chi-square. So how to do that? So chi-square formula, for that you have to know the uh,
Summation of
yeah, summation of, so what is the case? Summation of
O, summation of bracket OI minus
OI
EI
minus, yeah,
square
observed minus expected square divided
expected.
by
Yeah,
the
Expected.
yeah.
expected. So whatever is the observed value against that expected, we have to square those. So
Yeah, so for the to all the cases, you have to make, and you will get a value. Now, so I'm just stating the what you have to do. Now you have to evaluate the, or you have to calculate the degree of freedom, the number of row and column minus one, and square of the product of that. So three. So if you look at here, the three columns and so three are there, and here also three are there. So two are there, so it will be 3 minus 1 into 2 minus 1. So that will be 2. So now a chi-square table will be given. So for the chi-square table, degree of freedom 2, or a significance level of 10%, what is the value? That is 0.1. And the chi-square value needed to reject the null hypothesis is
the degree of freedom, this is R minus 1, C minus 1, that only formula we have used,
yeah,
right?
yeah, 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 yeah. Okay.
Yes.
So now for this one, point one, you have to see what is the value actually. So if
But
we,
my value is coming out to be 3.85 in in this case.
How
okay,
come?
3.85. Let me note this. Okay. So how? I mean, what are the digits you are putting? What are the values you are putting? Please see here and make it clear now, so that I can at least inform that. So
So
this.
similarly, in the case of not sick, we have to calculate the expected value
Mhm.
and the sum over all, taking all the cases and sum over all the values. The calculated value of chi-square is coming out to be 3.85.
No, I'm saying that can you elaborate what are the numbers you are putting, what are the values you are putting, and so that you are reaching to this 3.85 value. That's what I'm saying.
Okay.
So you are
Okay, sir.
calculating this one, right? So
Yes,
for
sir.
this, yeah, I'm saying just state the number so that I can see what is the problem, so that I can inform at least.
Okay, sir.
Yeah. So you.
So in case of placebo, the expected value is coming out to be 40.64.
Mhm.
So chi-square formula is 50.0. observed value is 50 and the expected value is 40.64. So 50 minus 40.64 whole square divided by the expected value 40.64,
Okay, correct.
which give the value 2.155.
Okay, correct. Now,
And the second, in case of lab A, 44.70 minus 40 whole square divided by 44.70, that give the value point
70, 44.70 minus 40. Okay,
whole,
divided by
whole square.
divided by 44.70, right?
Yes, sir.
Yeah. So that is, and the value is
The value is 0.4959.
okay, and the third one is
In case of lab B, 40.64 minus 36 whole square divided by 40.64.
okay, and it is coming out to be
3.59 or I think.
The total,
no. So the last value you just tell.
yes, sir.
Test stats.
0.529.
Correct. Okay. Now the summation is coming out to be, as you were saying, 3.85, right?
3.855.
Okay.
Actually, it comes
Sir,
to
we have to include
3.955.
the not sick cases also, no?
Yes, of course. Like you have to
Yes,
consider the not sick cases also.
yes,
So
sir. So plus
otherwise, hmm,
150 minus 159.35.
yeah. So obviously this one and so these two values will be changed, right?
Hmm.
Uh-huh. So then and now you do the math. So what is the value coming out to be calculated quickly?
The total value after calculating the all these six cases is equal to
3.95.
3.855.
For me, it is coming 3.950. Yes, that's
Okay.
I'm getting 3.855.
yeah, because I didn't take the digits 41 point like that. I have rounded up
Yeah,
to
that's okay.
41.
That's okay. I mean, more or less, you will be in the similar
Yeah,
region.
3.95, that is what I am getting. Yeah,
Okay.
because I
Okay.
rounded up. Yeah.
Okay. So now, so and here the value is 4.65, right? So it is 4.65,
4.605.
605,
So the
right?
calculated value is less than the tabulated value, 4.605. So null hypothesis accepted here.
Yeah. But the answer is actually rejected since it is greater, right?
Yes, yes, sir.
So it is 3.950. So it is null
Okay.
hypothesis.
So, okay, I will see. I will note. I will about this problem. I will contact because this is problem. Yeah. Okay, I'll get back to this problem. Okay, there's no problem. I'll talk to the instructor and the other TAs also. So, what is the problem that is people are facing? Because based upon these, we will do in the exams as well. So that is. Well, don't worry. I'll talk about this problem. Okay, but the overall thing is that you understand that how to sort out the how to solve this problem, right? So that is the major thing. So. Uh, I mean, we'll practice more. I mean, similar kind of problems. So since this, I mean, these with these formulas and all these things, all of you are okay, or you have some kind of problems. I mean, applying the formula. I mean, now yeah, now the calculations are wrong. So whatever the answer has came that is not matching, that is okay. That I will talk to them. But what I'm asking is that you are comfortable with the formulas, right, and how to apply.
Yeah.
Okay, so then
Yes, sir.
yeah, so then
Okay.
that is okay. I mean, at least here, I mean, what sir was saying that I mean, few people are facing problem in applying the formula, so try to handle them. Okay,
Sir,
so
this
Sir,
chi-square
one
table,
thing I want to ask.
sir, this,
yeah, yeah, just one by
Uh,
one.
can you please describe the procedure irrespective of going at 1 to 2 figures.
Yeah, I'll what I'll do that, let
Specific.
me talk, yeah, let me ask about the what is the exact actual value, or it is problem right or wrong. So I will give a total procedure in the while uploading this, so there's no problem, and I will discuss again. Okay. So since this is the debate is there regarding the value, so I am holding for now about this problem or similar this kind of problems. So let me get back to you after
Yes,
asking.
sir. This has been reflected in our assignment score also.
Yes, yes. So if it is wrong, so you'll get the marks. So there's no
Okay,
problem in
okay.
that. That will be auto
Actually,
corrected in
this
the.
is no. This is what you have shown is
Sir,
not.
please repeat that problem. We are not getting, sir. Please.
No, no. I'll
Please
what
repeat
I.
formula.
Okay, okay. So what you have to do, so I am repeating that I'll get back to you with the full solution once they clarify about this, because there's a problem and the a debate in the actual answers or the numbers that have been given as a solution. But what you have to do that you have to first make a table with the sick and non-sick and a total number of that, and make a table basically, and have to calculate the row and sorry, number of row and number of columns. And so from there you have to calculate the total number, and important thing is that you have to calculate an expected value. And how to calculate the expected value, you can calculate by
So simple, the expected value formula is Ci into Ri. I is
yeah,
in the suffix.
yeah,
Ci into Ri divided by capital N.
yeah, actually I should have given that ci into, okay, let me go on and write
In
like
this
this.
case, what is value of CI and RI?
Ci
So that is row.
as
Yeah,
I
yeah.
is going from 1 to 3. So there are three columns and two rows.
Yes.
Sorry, two columns and three rows.
Madam, value will be 126 and 200.
Yeah, yeah, correct.
Yeah, yeah, correct.
So Ci
CI,
into column total. Yeah, column
yeah.
total into
So
row total divided by grand total.
Grand total.
CI into RI divided by grand total, right?
Grand
Grand
total.
total. Yeah.
Capital N.
Divided by.
Divided by n. So this is the formula for your calculating and the expected value.
Yes, sir.
Pardon me for this bad thing.
What is the value for the expected age that we had mentioned of 2.115, and the second one is what?
So yeah, so first value is total value. You can understand from here is 126 coming out, right?
Yeah,
So
Yeah,
that
yeah.
that is
and Ri, and the other value for the control one or the placebo one is 200. So for the placebo one, the expected value will be 126 into 200 divided by this total value is 620.
620.
Yeah.
620.
So
Yeah,
yeah,
yeah, correct.
It comes to 44.70.
44 point.
44.70.
Yeah.
Yeah,
Okay.
that is 44. Yeah.
Now for the lab one, it will be 126 into 220 divided by 620. So
Yeah,
let me
yeah.
write, otherwise it will be confusing.
0.20.
And for the lab B, it will be 126 into 200 by 620. Same for the placebo, similar. The
Plus.
value will come as
Yes.
similar, right? Now,
Similar.
once you have done, so you can from here also you can so this is done. So the expected values you can put it here, and in the round you can make it round up and put the values. Now the what is the probability of getting sick out of this total batch? So that is 126 is total number of sick is coming, and total value is 620. So this will be changed. So this will be 620, and this is 126. So 126 upon 620 is coming out to be 0.20, right? Now, what you have to do, you have to calculate the chi-square value. So, chi-square value, how to do? Before that, you have to calculate the degree of freedom.
Observed value and accepted value.
Yeah, observed value and expected value. So, the
Hmm.
degree of freedom you can calculate from Ri minus 1 into Ci minus 1. So, number of row minus 1 into number of column minus 1. Okay. So once, so you can see the number of rows and columns are number of row is 3, sorry, yeah, number of row is 3 and number of column is 2, seek and non-seek, and number of row is 2, so that is 3 minus 1 into 2 minus 1, that will be 2. Now you have to calculate here, here it is important. So it is observed value and the expected value you have calculated for each case, seek and non-seek for every batches. The total 6 data set will be there, right? So for lab A, placebo, and lab B. So for seek and non-seek, every value you have to put. One is expected OI, observed value, minus the expected value that you have calculated, square of that, and divided by the total value, right?
Total value.
Yeah. So in that way, you will get a number. Now from that, now you can look into the chi-square table, and from there you can get a number, which is what is the value that you are getting. Now, if the observed value, I mean, if you are getting the value that is greater than it should be that is there in the table, then you can reject the hypothesis, or if it is lesser, you can accept the hypothesis. Okay, this is the overall case. Now,
So in this, actually, the hypothesis is accepted
yeah, yeah,
because the
that's what
yeah,
you have said. All of you have said that, agreed basically, that it will be accepted. The value is
accepted.
actually, yeah, accepted. The value is coming lesser to the what is there in the table.
3.950 it is
3 point
coming,
something,
and
whatever.
observed value at
So,
significance of level at 10% is 4.605. That is why it is
What
accepted.
is the exact value chi-square? 3.9?
3.95 is the chi-square value,
Yes,
which
yes.
is lesser than the degree of freedom 2 if
3.95 or 3.92?
no, no, no. 3.950 is the value
I
of the
think there is also
chi-square.
debate. Someone said 3.85, 3.95,
Yeah,
and
because she has
3.92.
taken, yeah,
Yeah, you have
because she
taken.
has
I got a
taken,
3.85.
yeah, yeah,
I got
Yeah,
because
yeah.
she has
3.8.
taken in decimal, and I have rounded up those, like 44.8, I have rounded up.
Yeah, I got 3.92. Okay. Okay, these are due to decimal
Yeah,
difference.
yeah, okay. There is not. I mean, you just forget about now about these things, because anyway I'll
Above
get
the
back to
3,
you.
it will be accepted. No?
About the you'll be accepted. So yeah, so similar problems we will discuss again. There's no problem. I didn't include the problem of previous year because it's similar problem. Almost the data are also similar. That's why I have not included. But I will. So I didn't include again many problems because I thought of first be familiar with these things, and then we can discuss in the next. In the next assignment, I think not much mathematical things are there, right? So that's why we will do more, we'll practice more often or more of this. I'll with some more problems, I'll get back to you. So okay, anyway, so not much about this session or this assignment. I hope we are now okay with this kind of problems. So the next week we'll first discuss about assignment 9. I will conclude basically today. I mean, not much about this week any further. So we'll talk in the next week. We'll first talk about assignment 9. So after assignment 9, and then we'll discuss more about these kind of problems about, I mean, this Z test and T test, and then we'll see two more will be there. So let me
Sir,
just.
I feel this because why people are not understanding this is because it has to be put in a very systematic way that how did we arrive at that rows and columns. So I think if you do that, then they'll understand quickly. Like
So
on the accepted value, like what we calculated, no, that CRI and grand
Yeah.
total. So
Expected
if
value, that
so if you
formula
put
was not.
all the if you put all the EI, OI, and in the columns next to, so probably this
okay,
is the
okay, okay.
Systematically, so that we will get
Yeah, yeah, I
easily.
understand. I
yeah,
understand. Okay. Yeah,
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 sure, sure.
yeah.
So yeah, that I'll do. That I'll do after
Mm.
talking to sir.
Sure,
I'll
sure,
do. Yeah, yeah. Okay.
sure, sir.
So yeah, yeah. So let me just check quickly what is there in assignment 9. I hope you have already submitted. So
Yeah,
Yeah,
sir.
in
And
assignment 9, so there is very few mathematicals are there. These are their mathematicals, but are these you are okay? How you have done here for this
No, sir, there are
This is
many.
not
Not
the
okay, sir.
this is on the
first,
measurement
Yes, I got
No,
error
not a
first,
problem, not a problem.
extender
regression
error.
Okay,
analysis
okay, okay,
actually.
okay. I understand. It's okay.
It was
So
okay,
First
sir.
dimensional problem is okay, but the latter two are not
yeah,
so easy.
yeah.
so which are
I
problem?
could not tell extender error.
Okay. Okay, then we will discuss about this. No problem with that. So we'll discuss about this first, and then we'll discuss about the problem that is there, right? So that is not an issue. Okay, so on that note, I will conclude today. I have not much to say about assignment 8 problems. So we'll see you all in the next week. Okay.
Okay, thank
Okay.
you.
Okay. Okay. Thank
Okay.
you.
Thank you.
Yeah.
Thank
Yeah.
you, sir.
Thank you, sir.
Yeah. Yeah. Thank you.
Yeah.
Thank you, sir.
Yeah. Yeah. Thank you.